Hello everybody, welcome to Bill Sky the Rust Guy, and we're going to get into the very first inklings of artificial intelligence in Rust, well any language for that matter, simply by using if statements. Asking questions, getting answers, and then acting upon those answers. So you hear a lot about AI. You actually hear a lot about AI that really isn't AI. It's just very good software. I shouldn't even say good software. It's just software that has if statements in it. So within a program, if all you're going to do is print stuff and read stuff from a file, if all you're going to do is very basic stuff, you may not need if statements. But that is unbelievably rare that you ever need stuff like that. Or you're ever going to write a program like that. You're always going to have to make decisions, just like you make decisions when you drive down the road or take your bicycle down the road. Like I did today, I rode 20 miles. You have to make decisions constantly, and that's what if statements are all about. There's going to be another video on a thing which is like the switch statement in C and C++ and Java. That's another way to make decisions, but the one we're going to talk about today is just the basic if statement, how you ask questions and how you act upon the answer. So let's get right to it. Okay, so today I'm not going to use Genie. I actually love Genie, but today I'm going to use Visual Studio Code. Not Visual Studio, but Visual Studio Code. And I actually have a project there already, but I think it'd be kind of nice to go ahead and start from scratch. Now, the way that even Microsoft recommends that you use Visual Studio Code for Rust is that you open up a terminal and you use Cargo to actually create your project. So what I'm going to do is, before that though, I'm going to open up my file manager, and you can do this on Windows. I'm on Linux right now. It just doesn't really matter. So I'm going to go to my Rust projects. I'm going to get rid of this if-else2. So I could have done that, I guess, with the delete. And what I'm going to do is I'm going to change directory to Documents. And I believe it was Rust Projects. I could have done this from the file manager. And I'm just going to say Cargo new if-else2 and press enter. And Cargo, if you don't know, Cargo is a really nice tool that comes with Rust that allows you to manage projects. And there we go. So I've got my if-else2. And if I ls, I can see, or dir if you're on Windows, I can see my if-else2. So what I'm going to do is I'm going to change directory to if-else2, and then I'm going to say code dot. And dot simply means the current folder I'm in. So because we changed directory to if-else2, I say code dot, it says load Visual Studio Code in that directory. And you can see that we've got our directory. We've got our source folder, we've got some of the cargo data there, and I'm going to go ahead and expand src. I'm going to open up main.rs. Okay, so now to build using this, I'm going to go up here to terminal. I'm going to say a new terminal, and you can see I'm in if-else2. If you're not in if-else2, you may have to do something like this to get you into if-else2. And what I'm going to do is I'm just going to say cargo build, and I got a green finished. I'm going to say cargo run, and it says hello world. So we've got it all set up. So let's get into some decision making. Let's get into some if statements. So before we do anything with an if statement, I'm going to need some data to ask questions about. So I'm going to say let mute and int unsigned 32. Let's just create a few unsigned 30. Let's stick with 32-bit today. And then I'm going to say, let's do a string. I'm going to say let mute a string equals hello there. Now, why am I putting a string there? Because you can actually make decisions based on strings. Hello world. And I always like to say println just so I know that the program actually ended without any issues. Okay, so I'm going to go ahead and press Control S because I'm on Linux. On Mac, if you're on a Mac, it would be Command S. And I'm going to go ahead and build it. run it, and it looks good. Hello world, this is my if-else project. Okay, great. So we've got our variables. Now, Visual Studio Code and or Rust is telling you that I'm not really using these, so why have them? Well, that's just because we haven't done anything yet. Okay, so let's ask a very simple thing. What I'm going to do is I'm going to go ahead and say an int equals 1, 2, 3. So that's the first thing I'm going to do. I'm going to give my second integer a value, and the string right here is, I'm not sure what this ampersand string is. Wow, what's Visual Studio Code doing to me here? It kind of looks like Visual Studio Code put something in there for me. It seems to build okay. This is why I don't like integrated development environments. I like editors because it's doing something for me that I may not want it to do. But anyway, we'll see what happens. Okay, so we gave our integers a couple of values. Now let's ask if an integer is equal to something. So I'm going to say if an int is equal to 0. What do I want to do? I want to print something. Print ln. Okay. Now, in C and C++ and Java, you would actually put this line of code in parentheses. In Rust, you don't. You don't put those in parentheses. Also, I don't think this will compile. Let's go ahead and save this. This won't compile because in C and C++ and Java, you can write an if statement like this, but in Rust, you must have the open and close braces, which, by the way, I absolutely love. I love having open and close braces. It says this group of code, even if there's only one line, this group of code should be executed. So now, what is this statement doing? I'm asking a question. If the variable an int has a value of, a double equal sign is a logical equates. The left is equal to the right. A single equal sign is actually an assignment character. It's an assignment symbol. It means move the value from the right to the left. The double equals is asking a question. Are they equal? So is the value of an int equal to 0? If the answer to that is true, the first set of, or the first open and close curly bracket will be executed, and you can see it'll say print line and int is equal to 0. Okay, so let's go ahead and save that. Let's build it. And now it built fine. Let's run it. And, well, really nothing happens because we didn't do anything if that answer was false. So what I could do is I could just say print ln and int is not equal to 0. So we could do something like that. So let's go ahead and save and build that. And there we go. And int is not equal to 0. Now there's a huge problem with this. And that is, what if an int is equal to 0? What if I change that to be equal to 0? So I'm going to go ahead and build it, run it. Now an int is equal to 0 because it passed this test successfully, but it also printed an int is not equal to 0. And that's because once the contents of the true portion of an if is executed, the code begins after the if close brace. So it's always going to print this whether or not an int is equal to 0 or not. Now, how can we get around that? Well, I'm going to say else. And else simply means what should I do if the result of the if is not true, is not yes? What if it's false? What if it's no? It's not equal to 0. Well, now we have the else. So let's go ahead and save and build that. And run it. And you can see an int is equal to 0, and no longer is it printing this because we encased it in an else. So the way that this works is that if an int is equal to 0, if that's true, it'll print this, it'll skip the entire else section, and it'll continue the program. In this case, the program will end. If an int is not equal to 0, if that is false, it ignores the true portion of the if, and then it goes down and it does the else portion. So that's how that works. Now, what conditions can you do? This is equality. What's another one you can do? You can say less than. The left is less than the right. And I wish Visual Studio would stop doing this. You can say greater than. The left is greater than the right. You could say less than equal to. The left is less than or equal to the right. You can say greater than equal to. The left is greater than or equal to the right. So those are a bunch of different things you can do. What about if it's not equal to? Well, I can say exclamation mark equals not equal. The left is not equal to the right. And I could expand on this one right here. The left is equal to the right. So those are some of the conditions that you can actually put in your if statements. Now, I'm going to go ahead and get rid of these, and I'm going to try something else. So I could say if it's not greater than. Can you do that? Can you say not greater than? Let's go ahead and save and build that. And you can't. Not greater than is not, but what if you wanted to say not greater than? What if I wanted to say if an int is not greater than 0? Well, what does that mean? The opposite of not greater than is less than or equal to. So the opposite of equal is not equal. The opposite of less than is greater than or equal. Let's actually write those down. So equal, not equal, less than, greater than equal to, greater than, less than or equal to. These mean the same thing, or those are the opposite, I should say. What's another one? Is that it? I think that might be it. I might be missing one. So those are the opposites. What does it mean when you say something is equal? Something is equal if it's not less than and if it's not greater than. So another way we could say that is equal to the same as not less than and not greater than. Phew, we're getting into logic here. Less, what is another way of showing less? Another way of showing less is not greater than and not equals. So this gets into this whole idea of Boolean logic. I don't really want to continue with this too much longer because I'll be putting you to sleep. But the point is you need to be very, very careful when you're doing your if statements. Are you asking the correct question? Okay, so let's go ahead and save and make sure I didn't put something weird in this. And what did we do? If an int is equal to 0, let's see. This is, again, why I don't like using IDEs. Look at what Visual Studio Code put in there. It put that use standard intrinsics rotate right because I put in a word right and it wasn't in a comment. Maybe that was my fault, but I'm just trying to take some notes here. And look what it did. It did something really strange. Let's go ahead and get rid of that and let's build it. And now it's back. Whew. That wouldn't have happened using Genie or the Vim editor or the VI editor or even Nano. So you're going to have to deal with things like that if you're using an integrated development environment while using Rust. Okay, so those are the ways that we can we can write an if statement. You can just say if with no else, which I don't think is logically correct. You should always complete your ifs with elses. That way you have actually considered what if that should not be true, or what if there's not a true result? What should I do? You've thought about that, you've tried to make a decision, And if you have them, even if it's empty, I've been known to do this. And you might look at this and say, what is wrong with this guy? I've been known to do this, actually have an empty else. Now, I don't know if Rust will even allow me to do that, but let's save that and build. Let's see if it'll build it. Yep, Rust does let me do that. Why would you do something like this? Well, one of the ways that I was taught to code is that whenever you have an if, you should always have an else. That way, you have actually considered the else result. If you don't have an else, you haven't really thought out the code well enough, or you haven't thought it out to completion. This was in a course that I took called Structured Programming, and my very first programming assignment, I was required, by assignment I mean job, I was required to complete all ifs with elses. So, and that way I could mathematically prove that my code, at least from the point of view of conditions, was complete. Because I would assign the number 1 to an if, I would assign the number -1 to an else. If you add all those together, you can then tell what is the completion, what is the completion of your code. Now, that doesn't actually mean that your code's correct. It's just another tool that we used to use in the past. So I'll actually do that just to show that, hey, I did think of else and I really don't want to do anything if the condition is an else. And this doesn't make your code, your executable code, any slower. It doesn't make it any bigger. The compiler takes care of all of that. So do what your company requires you to do, but do it for completion and so other people can read it very, very well. Okay, so let me go ahead and put that back. All right. Another way to do this, let's do something else. I'm going to do another one. I'm going to say if an int is not equal to 0. I'm going to show you how this is very, very similar, what I call negative logic, else so because we're using negative logic, we put the else portion of the positive logic if statement into the true, and we put the positive part of the non-negative logic into the else. So these will both do exactly the same thing. Let's see if I'm right. Let's see if we get that to work. And you can see we've got the exact same results from both of those. So it's also very important to think, where do I want to put my action based on the result of the if statement? Do I want to put it in the if, or do I want to put it in the else? Okay, let's talk about a complex if statement. Let's do this. Let's say if an int is equal to 0. What if we want to ask another question? Well, I could do this. If an int 2 is greater than 100, print ln. Oops. I'm about to say something bad about Visual Studio Code. I don't know how accurate these things are, but let's talk about this. This is what we call a nested if. What I did was, well, before I do that, let's go ahead and save it and build it and make sure it builds okay. Okay, great. So what did I actually do here? Well, I've got an if statement right here, and inside of the if statement's curly bracket has another if statement. And notice that if statement also has an else, and they're actually part of the curly bracket. And I don't know what happened. Oh, I accidentally moved it. I'm not doing this on purpose. Okay. So this if statement right here is actually inside of the first curly bracket from this if statement. So if this is true, another question is asked, and then action is taken upon the result of that. And there's the closed brace. Now, something else that I do, because you can imagine if you have a lot of these if statements inside of an if, you might lose track of what all the closing brackets are for. So what I'm going to do is I like to put in comments, because if it goes off the page, you know what closing bracket that closing bracket belonged to. Did it belong to an if? Did it belong to an else? I even worked for a company that had me do this. Actually, in a comment, put that in there, so I knew that that closing bracket was for that specific else. Ugh. I actually didn't like that, but I actually like doing this. I actually like putting a comment at the end of every closing bracket so I can know. Now, for a single if like this that doesn't take much room on the screen, okay, that's not a problem. But what about for an if that goes off the page? Once you're past that, you're like, well, what does this belong to? If that wasn't there, what does this closed brace belong to? Now you might say, well, it's showing a line up here. Visual Studio Code is actually showing a line, but now you've got to scroll up and say, oh, okay, it's part of an if. So it's a little bit more difficult doing it that way. But it's all style. Okay, I guess Visual Studio Code has a limit to the number of undos it can do. Okay. Let's run it. All right, great. Okay. So that's a nested if. I could even have an if in here in the else. I could say if do something else, do something else. So I can have as many. I could even do something like this. This can get pretty out of hand. You can get something that's pretty complicated, and you can see how it would be easy. In fact, this if-else is already run off the page. It will not fit on a single page. So that's why it's always good to have those closing comments for each closing curly bracket. But you can see this can get pretty complicated. And there's another way around this. It may not be as complete as this method of having nested if statements. But if you don't need real completeness, you can do what I like to call a complex if. So I can do this. I can say if an int is less than 0 and. So I'm asking two questions. I'm asking if an int is less than 0 and an int 2 is greater than 100. So what happens here is that if both of these are true, if both an int is less than 0 and an int 2 is greater than 100, then I want to do something. Else, what does that mean? What does the else of a complex if with ands mean? Well, that means if both of these are not true, then the else happens. So and is a condition where both options must be true. I could even do something like this. And an int is greater than -10. Now this is a horrible if, but I can do it. So because I have all three of these conditions, all three must be true. An int must be less than 0. An int 2 must be greater than 100. An int must be greater than -10. Okay? So you can do very complicated ifs. If all three of those are not true, then the else will occur. The else is kind of like the garbage collector if not everything is true. So that is ands. Now, what about or? What if I want to ask if one thing or another thing is true? So I can do the vertical lines here. And let's talk about what this one will do. Ors are different. Ors mean that if any one of those is true, then do what's inside the true section or the true area. If all of them are false, that's the only time where the else occurs. So this can become very confusing. So if an int is less than 0, or an int 2 is greater than 100, or an int is greater than -10, then do this. If any one of those are true, then do this. Else, if none of them are true, do that. So this, I guess this would work, but boy, you really got to think about this. And the thing I said a little while ago that nested ifs might be more accurate, I don't know if that's the word I used, is because I can't really tell the user what has actually happened here specifically. All I know with these ORs is that one of them was true. I don't know which one was true. I haven't been able to tell the user which one is true. So those just, it isn't as accurate. And to show you, if an int is less than 0, print ln, and int was less than 0. I believe I need an open. Yep, I already have it. Else, if an int is greater than negative 11, print ln, and int is greater than negative 11. Excuse my spelling. So you can see by using nested ifs, you can actually dig down and really tell the user what the situation was. This is an OR. This is the same thing. Where is that little puppy? Right here. This if statement, this is it implemented using nested ifs. Now I'm not quite done. Else, if an int2 is greater than 100, print ln, and int2 is greater than 100. So this is the nested if version of this, what I like to call this complex if. Now, as I said a moment ago, the complex if is not as accurate, maybe that's not the word, as the nested if. It takes up a lot less real estate, but look at what I can do here. I can specifically tell the user what actually happened in the if. Was an int less than 0? Was an int greater than negative 11? Or was an int greater than 100? And also when you look at this an int greater than negative 11 kind of goes away, because if an int, well, maybe not. If an int is less than 0, let's say it's negative 100, then you can ask if it's greater than negative 11. So you're asking, is it less than 0 and greater than negative 11? Or if you're interested in equals to, you can put an equals to in there. Okay, so if statements can become quite complex, and I really recommend that you, as you're writing your code, you really flowchart it. I really like flowcharting logic, especially when it gets very, very complicated. Okay. So what have we done so far? We've talked about ifs, we've talked about complex ifs, we've talked about if-elses, we've talked about different conditions, we've talked about nested ifs. So let's go in and now talk about, if-elses. Now there's an awful lot of code here. I'm going to actually get rid of a lot of this. And kind of start anew here. And if-else is kind of neat because, or else-if, or if-elses, else-if is what they're called. And what they allow you to do is allow you to have a nested like if that's a little bit more orderly. So I'm going to say if an int is less than 0, print ln, okay. If it's not less than 0, I can say else if an int is greater than 100, print ln, and int is greater than 100, else if an int is greater than 50, and you should always close it off. Okay, now we got something wrong here. Let's see. 0. Oh, I've got a funny little character here. I use the curly bracket inside of the parenthesis. All right, let's save this and let's build it. Yep, I still have a problem. So we have, again, I'm thinking of C, right? I'm thinking of C++. You don't use a parenthesis in your if statement. Okay, now it built. All right, so what are we doing? So the else if this is not true, I do an else, ask another question. If that's not true, else I ask another question. If none of those are true, we do the else. And it says, oh well, print ln, oh well. Let's see that run. Oh, it wasn't less than 0. Well, actually, what is it? It's 0, right? It wasn't less than 0. So if an int is less than or equal is less than 0, no. If an int is greater than 100, no. It does if an int is greater than 50, no. Else print oh well. And that's why it printed oh well. So else ifs are great for interrogating the value. Interrogating, I sound so official. They're great for asking questions about a single variable. You could do it for multiple variables too, but it can get quite confusing if you do that. But I've done that many, many times where I've written ifs, else ifs, just to go ahead and check the integrity or the value of a variable, of a single variable. It's kind of nice to be able to do that. It makes it very, very useful. Okay, so we've talked about ifs, elses, else ifs. We've talked about different type of conditions, less than, greater than or equal to. Let's now talk about comparing strings. What does it mean when you compare two strings? So I'm going to write a string here, hello. And I'm going to write another string. Which string is greater than the other one? Is the string hello there with capital H, is that greater than lowercase h hello there? You know something? You might say to yourself, yes, it's uppercase, it's capitalized. Of course it's more important. Well, you'd be wrong. It is not more important. And let me show you why. I'm going to go over to my web browser. And I believe it's ASCII-table.com. And the way that these comparisons work is everything in the computer is really, everything's numeric. There really are no characters. Everything is numeric. And what I'm going to do is I'm going to zoom in here. And the ASCII table is the value of, or the numeric value for each character. So let's take a look at, if you remember, it was hello there. One was uppercase H, the other one was lowercase h. Let's take a look at what the value of an uppercase h is. So the decimal value is 72 for uppercase h. What about lowercase h? It's 104. So what would actually be greater? The uppercase hello there or the lowercase hello there? It would be the lowercase hello there. So lowercase hello there would be greater than uppercase hello there. Now, how does it actually work? Well, what happens is the if statement, when you're comparing two strings, it goes one character at a time. So it'll say H, uppercase H, it'll say lowercase h. If that's it, if you're asking if hello there is greater than uppercase hello there, it's done. Because it's already found a character that's greater than. And let's put that if statement in there. So I'm going to go ahead and use a variable. Yep, it's a string. So I'm going to say if a string is greater than hello there. Print ln. And let's first see if this works. So I'm going to save, I'm going to build it. Okay, we have a problem. Let's see where the problem is. Oh, I have comments there. So let's go ahead, actually, let's make those comments. so we can keep them there. Okay, let's run it. Okay, so hello there is greater than hello there. Is that correct? So if a string is hello there, if a string is greater than hello there, okay, I think I have my output wrong. So yes, it should be. So this should be capital hello there. You see how easy it is to get messed up? And when you start getting into if statements and making decisions, it is really important to test things out. I like to test things out all the time, even after just making one if statement. Okay. There we go. Hello there is greater than hello there. So what happened? So it asked, uppercase hello there is inside of the variable a string. So it looked at the h. Is h greater than the lowercase h, which is over here on the right? If the answer is no, it's done. That if is done. It is finished. Even if I had 50 more, characters at the end, this string is greater than this string because it does things based on the ASCII table. And you can test this out yourself. You can go crazy with this, right? You can do all kinds of testing. But the way that it works is that it looks at this ASCII table one character at a time to decide which character is greater than the other one. In fact, if you take a look at it, capital Z has a value of 90. Lowercase a has a value of 97. So lowercase a is greater than uppercase Z. Ooh, that's just how they did it. So every character is represented by an actual numeric value, which is actually what is stored inside of the computer. So play around with that. It's actually very interesting. It goes one character at a time until it finds equality or lack of equality. Now I mentioned something about shorter strings. Let's say I was or longer strings. Let's say I was comparing these two. Uppercase hello there with a bunch of Z's at the end, and lowercase and uppercase hello there with nothing. In this case, this hello there would be greater than this hello there, than that hello there, because there are additional characters. So again, if the string is longer, if the string is identical with a shorter string, but then there's additional stuff at the end, then the left one will be greater than the right one. So it's always good to check that out. Now, one other thing you might think about doing is you might say if a string is equal to an int, println, so can you compare a string with an integer? Well, if you notice, even the integrated development environment is saying you can't do that. And if I move my mouse over, it says you can't compare a string with an unsigned 32-bit number. And if I try to build it, it tells me I can't do that. So that's one thing that's pretty nice about the Rust compiler is it tells you that stuff right away. So that is, you really can't mix types. If I wanted to actually change this, make this work, I could convert that into a string, and then I could do the comparison. But that's for another video. All right, wow, that was an awful lot. And you know something? I didn't even get into it fully. I gave you the general overview of making decisions in Rust, the if statement. We talked about if else, if else if. We talked about complex ifs using ampersand for and, vertical line for or. We talked about nested ifs. I think I might have already said that, and how you could actually do that using a complex if. But as I said earlier, complex ifs are not as specific as nested ifs, so it depends upon what you're doing. All these different tools. We talked about string comparison. It goes one character at a time. Lot to take in. What's the best way to deal with this? Try it yourself. Create some variables, try things out, give them different values, even maybe do some keyboard inputs so you don't ever have to compile it every single time. That's how you get good with a language. And next we're going to talk about that thing I called it a switch statement. I believe it's a match, but we're going to see it in the next video, which is another video on decision making, but that one deserves its own video. Hope to see you there.